Hello, good morning. I'm Elefterios from Greenstruct, Greece, and we are integrators of smart windows, smart glasses, dynamic glasses, BIPV, and every available technology that can be applied in the glass sector. So during the Reno project, first of all, let me introduce you very briefly to the BIPV technology. There are two main technologies. One called amorphous silicon, and the other is called crystalline silicon. So the AC, the amorphous silicon, is on the left photo. You can see it mimics the natural look of a glass pane. You cannot see the photovoltaic cells until you are very close to the glass, so you can see some stripes. And the crystalline technology, you can see the visible energy cells. So in terms of aesthetics, the amorphous silicon glass, as I told you, mimics the natural look of the regular glass pane, but the crystalline silicon has visible energy cells and much higher energy yield. So in terms of which one are you going to use in a building, it's up to the building design, up to the architects and up to the owners. If they don't mind having the visible cells, they can use the crystalline and have a much higher energy yield. Or if they want to go with a more aesthetic view of the glass, they can go with the amorphous silicon, have a lower energy yield, but a much higher aesthetic appearance. So during the Reno project, the task that we have to do is manufacture and implement an innovative installation method for the double facade BIPVs. Up until now, if you wanted to have a BIPV unit, photovoltaic glass in the facade, you must place vertical and horizontal aluminum profiles, and then have the BIPV glasses mounted on these profiles. So you have a lot of work done on site, a lot of man hours on site, and the task that we are going to perform during the Reno project is manufacturing a prefabricated module that is going to be fabricated in the factory, and is going to incorporate the aluminum profiles along with the BIPV glass and insulating panels on the back of the aluminum profiles. So you have a single sandwich module that you can just hang on the facade. Moreover, the interesting part of this module is that can be applied in blind facades. It can be applied in opening windows or sliding windows or whatever else you have on the building facade. It's a quicker way of doing an installation, and you can have also one very important thing concerning the BIPV technologies in facades and glass panes is that if you have a photovoltaic glass on the front of your building, then the glass itself produces a lot of heat inside the building. So it must be very well insulated, both in terms of glass panes as well as insulation on the building, because you will produce energy, but at the same time you will produce heat inside the building. So by fabricating this, by manufacturing this prefabricated module, we are incorporating insulation on the back of the module. So we are cutting off the energy heat coming into the building. This is for the module. Please, can I have the second? Yes. So the second technology that we are dealing with in Reno is called thermochromic glass. Thermochromic glasses is a dynamic glass technology. It's a newly relevant technology that uses the sun heat to darken a glass pane in order to cut off all the harmful elements from entering a building. The principle of this glass is that when the temperature of the surface of the glass rises, then a thermochromic layer inside the triplex glass reacts and darkens, resulting in a tinted glass. Up until now, the problem that many people had in their facades or in residential projects is that if you want to cut the excess heat entering the building, you must have a dark tinted glass. But if you have a dark tinted glass, then you cannot have a very good viewing outside of the building. So it's pretty much a weighted decision. So do I want to see the view outside, or do I want to cut the heat? There is no middle. There is no middle solution. But because of the very high rise of the dynamic glasses technologies, at this point of time, we can have both viewing and energy cutting. So the thermochromic glass is a technology that goes into the dynamic glass sector, but it's not using any electricity. We have also the electrochromic glasses, but they use electricity to darken. So the thermochromic glass is a glass that you can just put it in an IGU unit and just leave it there. There is no external interference in the glass. It regulates itself. So if you have a cold day, let's say at winter, the glass doesn't become dark, so it doesn't cut off the heat entering the building. But if you have a sunny day in the summer, the glass regulates itself, so it cut off all the excess heat entering the building. It's a very smart way of dealing with the heat inside the building. And also one important thing is that because we already spoke about the BIPV technologies, also in the ENVISION project, we had requests in the past for combining the BIPV glass along with dynamic glasses on the back. So you have both of the worlds combined into one glass. You have energy producing on the front, and on the back you have heat cutting technology. So it's a win-win situation for the building. Can I have the next slide, please, Valentina? So the technology is called the BIPV double facade. The partners involved are we are integrators, so we had many partners involved, but especially I wanted to mention the contribution of EKETA from Mr. Nikolopoulos, Mr. Soukakis, and Mr. Komninos, because they are giving us their expertise in energy management, and we are doing all the practical work. So BIPV double facade module will be a new way, as I'm saying, of installing photovoltaic glass technology into building facades. It will be prefabricated at the factory, and it will include the aluminum frame along with the glasses, the BIPV units, and optional insulation panels. Whatever insulation panel you want, you can install it on the back of the glass, resulting in a ready-to-install module to the hanging brackets on the building. The innovation during this project is first of all the change in the installation type of the BIPV units. The typical and the most used case for installing a PV double facade is, as I already told you, by installing aluminum profiles all across the building facade, and then installing aluminum components on these profiles, and finally installing the PV glasses without any insulation. But during Reno, by doing this prefabricated module, a new installation method will be developed and applied in demo sites. And by doing that, we are going to make a much easier and faster type of installation, because all the components are going to be pre-assembled in the factory, and we are going on site just to hang them on the building. Next, yes. So the target market for the BIPV modules is the facade applications, the windows applications, the skylights applications, and the balustrades. You can pretty much use it in every available application that you can use a normal regular glass. The market size now and the trend for these kind of glasses, it was valued at 14 billion US dollars in 2020, and it's going to expand on a rate of 20% from 2021 to 2022, 28. As I'm saying here, crystalline silicon technology dominated the market because it was a much easier way of making BIPV units and a more cost-effective way, with a share of over 70% in 2020. But now the AC technology is starting to picking up because, as I already said, it's a much more aesthetical, appealing application in the building facade, because you can have a regular glass feeling with the amorphous silicon technology. Potential customers for these technologies are developers, construction companies, the home owners, and the architects. And the thing with these potential customers is that many of them, they don't even know the technology, so we must educate them and we must show them the results, the actual results of using such glass technologies. The benefits for the building owners and all the other tenants is that BIPV technology not only produces on-site clean electricity without requiring any additional land area, such as the regular photovoltaic panels that you can install them on the roof, but can also impact the energy consumption of the building through daylight utilization and reduction of cooling loads, because you are using it inside the double insulating glass unit. And the BIPV can contribute to developing net zero energy buildings. Actually, it's the only way to make a net zero energy building, because if you want to use regular photovoltaic panels, you do not have the area to use them. You do not have enough area in the buildings, just the roof. So next slide, please, Valentina. The thermochromic glass. The thermochromic glass, as I told you, is a newly developed technology and uses the sun heat to darken glass pane. The core principle is that we use a thermochromic interlayer inside a double laminated glass, and this thermochromic film darkens itself, resulting in a tinted glass while keeping the visibility at all times. The innovation, the innovative element in this glass is the glass itself, because every glass surface in a building had a standard tint or no tint at all, resulting in fixed technical properties such as G value, solar heat gain coefficient, and other technical aspects. And that means that if we want to have a well-insulated glass surface, we must use a very dark tinted glass, even a mirror glass, in order to block sun heat and all the damaging rays. But this tinted surface, the thermochromic glass, remains the same throughout the year. So we have a maximized view and the rejection of all undesirable sun heat. We allow with the thermochromic glass, we allow the sun heat to enter our building in winter and heat it up properly. But we reject the sun heat in summer, creating that way a building that is self-regulated, and it's a very important thing. The target market for the thermochromic glass is pretty much the same with the BIPV. So we have the windows of a building, we have skylights, in residential projects and workplace projects and healthcare projects, as well as hospitality. The smart glass market size was valued at $4.5 billion in 2020, and it's expected to expand with a growth rate of 6.8% from 2021 to 2028. The energy conservation initiatives, such as the green buildings, as we already said, for the BIPV units, and eco-friendly structures globally is expected to offer very promising growth prospects to the thermochromic glass market. The potential customers for this technology is pretty much everyone that is inside the construction chain, including developers, construction companies, the homeowners, and the architects, the same as the BIPV market. And the main advantage of the thermochromic window is the control of heat gain inside the building and the reduction of the glare based on the level of light outside. So we have the good of both of the worlds. We have the glare reduction and we have the heat gain reduction. And this type of glass allows natural light to enter while automatically providing protection against heat and glare. The conclusion, yes, the main conclusion is that the buildings, especially in Europe, they're falling behind in technology advancements, and the reasons for that is mainly the lack of funds and the lack of knowledge. So the companies which are producing these innovative technologies every day, the homeowners and all the other people involved in the construction chains are hard to reach these technologies because they don't have the necessary funds, first of all, and they don't have the necessary knowledge. The Reno projects and all the other projects like Reno and ENVISION, they are the necessary projects in order to showcase these eco-friendly solutions to people from different sectors, both architects, homeowners, developers, in order to adopt these technologies, these solutions, and advance the aged building stock that we have at this point of time.